And yes, the chemistry could potentially support early life on Titan, but it's not warm enough. It's too cold and it doesn't have access to water and energy that it would need. But you could speculate about some other ways perhaps that it could have liquid water. We know, for example, that meteorites have come to Titan and hit the surface, generating heat and bringing energy with it, and perhaps for certain amounts of time, then that would mean that there could be pools of liquid water there. So it's really interesting to think about and speculate about the possibility of life in other parts and other locations of our solar system, and Titan is a very interesting place to look into those questions, and that's why we're going there.
Once the spacecraft gets to Saturn, how will it collect data? Will it use rovers like the Mars rovers?
No, actually, it's going to be rather different from the Mars mission. We're not sending rovers like Spirit and Opportunity. It won't be trundling around on the surface like we did on Mars. First, we're sending the Cassini spacecraft, and it's an orbiter, and when it reaches Saturn, it'll actually spend the next 4 years there, kind of doing a grand tour through the Saturn system. And one of the things it will do is about 40 flybys near Titan, collect information, kind of a big picture view of Titan. But then in addition to that, we have a Titan probe, Huygens probe, and that was developed by the European Space Agency, and it'll drop down through Titan's dense atmosphere and all the way down. The instruments will be taking all kinds of measurements like the density of the atmosphere and the temperature and altitude and things of that sort. And of course, it's going to be taking a lot of data, a lot of information about the chemistry of Titan's atmosphere, what kinds of things are there and how much. And it'll take about 2 to 2.5 hours to get all the way down through the dense atmosphere. We don't know what it will land in, but it will be able to stay on the surface and then in its local area kind of take some measurements and also radio that information back to the orbiter and back to Earth.
The next generation of science missions to Titan will probably be much different than the missions of today. Because little is known about the moon's geology, one type of mission concept recently developed by NASA would rely on a dirigible type craft to move through Titan's atmosphere, taking multiple measurements over time. This blimp would float above the surface and deploy a small probe to sample Titan's atmosphere, methane crater lakes, and crater rim ice. The probe would be able to analyze the samples on the spot and then relay the information to scientists back on Earth. With Earth nearly 800 million miles away, the probe would need to be almost completely autonomous. This type of craft could conceivably float through Titan's atmosphere for many months, gathering valuable evidence about Titan's chemistry and geology and what that means for us back on Earth. Realistically, what are your expectations? Are you expecting to find life on Titan?
Scientists try to be very objective, and only have attitudes and opinions based upon what we know, of course. And so I think a lot of people are holding back and saying, I don't expect to find life there. It's too cold. Even though we have extremophiles here on our planet that can live in very dry or very cold conditions, it's really cold out there, and there isn't liquid water. So we're not expecting to see anything there. But the nice thing would be is if we could find, I think a lot of people would be very, very happy if we saw some serious complex organic chemistry going on. Clearly prebiotic chemistry would just be wonderful. Going to other destinations in our solar system and then gathering this kind of information could really help us understand how our planet formed and how life originated on our planet. And these were really profound questions, not just to scientists, but to everyone. And so I think it's really interesting and great that NASA can send spacecraft and gather these kinds of data to help us answer those kinds of questions.
After a nearly 7-year journey, Cassini-Huygens entered orbit around Saturn on June 30th, 2004. On Christmas Day of 2004, Cassini released the Huygens probe on its journey toward Titan. Finally, after a 20-day ballistic freefall on January 14, 2005, the Huygens probe entered Titan's atmosphere. It deployed parachutes and began 2.5 hours of intensive scientific observations while transmitting data to the Cassini spacecraft. After making contact with the ground, the first ever pictures of Titan's surface were finally seen back here on Earth. Coming up, we'll find out more about robotic missions that will pave the way for humans to travel to other planets. But first, did you know that the Cassini mission is studying more than just Saturn and Titan? In fact, recent images by Cassini have shown spectacular evidence that another one of Saturn's moons, called Enceladus, is geologically active. Cassini's cameras have captured pictures of jets of fine icy particles streaming from the moon's south polar region. Because this moon is so far from the sun, it is believed that the energy source for the geyser-like activity is due to internal heating by perhaps radioactivity and tides. Researchers hope to learn more on subsequent flybys by the Cassini craft.
One of NASA's stated goals is to go back to the moon and explore Mars and beyond. To reach these goals in a safe and economical way, NASA planners are using an approach that will first use